Hey guys, what's up? I'm back here and I'm back with the next topic from biomolecule. And what this is actually, this is the first polysaccharide, that I'll be discussing today. There are three polysaccharides you have to study in biomolecule. The first one is starch, second one is glycogen, and third one is cellulose. So out of these three, starch is the today's topic. Now about starch, what you already know is that it's a polysaccharide that is made up of alpha D glucose only, right? So it's a polysaccharide of alpha D glucose. How do you get to know that it's made up of alpha D glucose? It's very simple. What you have to do, you have to do the hydrolysis of starch, right? What is the starch here? Starch is a very common substance that you find in rice, corn, and there's so many things, right? So this is one of the most common, carbohydrate that we in our day-to-day life utilize. So a starch, is a polymer, is a biomolecule, is a macromolecule, and it consists of alpha D glucose, right? So in order to make you go some writing part, what you need to do the preparation here. So I'm talking about starch. So like I said, when you do the hydrolysis of starch, what hydrolysis means? It means you are dissolving starch in water in presence of small amount of acid, and what you get alpha D glucose, and you get actually large number of alpha D glucose. So N is the number of glucose that you will obtain once you do the hydrolysis of the starch, right? Now, what we have to do now, we need to understand, the structure of the starch. I tell you what, a starch molecule basically consists of two units. Remember, a starch molecule consists of two units, and these two units are called amylose and amylopectin. But both of these are again made up of alpha D glucose. So there's nothing to worry. Is there anything else you might be looking? So let me repeat back. A starch molecule is divided into two units. One is called amylose, other is called amylopectin. But then both of these units are again nothing but polymer of the alpha D glucose. So we need to understand, about these two units. So one is going to be amylose, other is going to be amylopectin. So what I'm doing here, I'm dividing this starch, just pay attention here. I'm dividing this starch into two components. Like I said, one is your amylose, and other is your amylopectin. This is your amylopectin. In case you have problem, let me repeat back. All I said was, starch is divided into two units. One unit is called amylose and other unit is called amylopectin. Now, the thing is that amylose, the first thing is that amylose, consists of alpha D glucose. It consists of alpha D glucose. But again, even amylopectin is also made up of, consists of alpha D glucose. So this is again, made up of alpha D glucose. So this looks like a similarity here. Let's talk about the second point. The second point is that amylose, is a straight chain molecule. What that means? It's unbranched. However, this amylopectin is branched. How this branching is, happening, I will definitely describe you with some structure here, but let me brief you the difference between amylose and amylopectin, right? But in case you want to make it go right here, then let me finish the third one. The third one is that being this, straight chain or unbranched, this is water soluble. But this amylopectin being highly branched is water insoluble. This is water insoluble, right? So what fourth is here is that this, it has glycosidic linkage between C1 and C4, between C1 and C4 of alpha D glucose. But this one has glycosidic linkage between C1 and C4, and also between C1 and C6, at branching. Okay, let me explain you this fourth point here, because not only writing is not only enough here. The thing is that this amylose is a straight polymer, a straight polysaccharide, where alpha D glucose are linked together using their first and fourth carbon of the adjacent alpha D glucose, right? However, this being branched, the branching is happening at 1 and 6 carbon of 2 alpha D glucose molecule, but the straight chain is arising again between first and fourth. In case you have problem, you are not getting exactly, just wait, I will draw the structure and make you understand what I am talking about, right? But remember, this is not some difficult part, this is again something very easy. And why it's easy? Because you've been doing this for last couple of days, doing those glycosidic structure, glucose, alpha, whatever, and all that. So that's why I would say this is going to be really easy. But let me repeat back here. A starch molecule consists of two units. It's called amylose and amylopectin. Amylose consists of alpha D glucose. This one also consists of alpha D glucose. So this first point is nothing but a similarity. Second is amylose is a straight chain molecule. However, this amylopectin is a branch molecule. Amylose is water soluble, but this one is water insoluble. There, the fourth point is very significant, that the alpha D glucose are linked, using their first and fourth carbon. One of them is using first, other one is using fourth carbon, and there is a glycosidic link formation between the first and fourth, right? But it still remain a straight chain. But what is happening here? There, the glycosidic bond is, the glycosidic bond in amylopectin is formed at two different locations, right? Some of the glucose are linked by first and fourth, but some of them are linked by using first and the sixth carbon. How? I'm going to draw that, but let me finish this particular, topic right now before I come to the structure. One more differentiating part is that it constitute 15 to 20% of starch, 15 to 20% of starch. However, this amylopectin constitute, like you probably know, because this is going to be 80 to 85% of the starch. So these are, let me tell you, these are differentiating point, but this one is a similarity, right? Let me repeat back the differences here. Amylose is a straight chain molecule. It is water soluble. There the bond is only forming between first and fourth, and it constitutes only 15% or about 20% of the starch. But amylopectin, you can reverse every aspect, and then you will get the differences, right? And what the differences are? First, it is branched. It is water insoluble. There the bonding is between not only 1 and 4, but some glucose molecule have also bonding between first and the 6, and it constitutes about 80% or 85% of the starch. But now this is time to come to the structure part of the starch, right? So there I'm going to help you how the amylose is having that bond between first and fourth, and how the amylopectin is not only having bond between first and fourth, but also between 1 and 6. So in case you need, just take a screenshot here so that I can remove this off. Done? So like I said earlier, amylose is having bond between C1 and C4. I'll show you how this happens to be. Suppose this is your alpha D glucose molecule, which is very, which is very simple structure. Why? Because you've been practicing this for last so many days. So there you have your first carbon, second, third, fourth and fifth, and you have your sixth carbon right here, CH2OH. So this is your sixth carbon and this is your first carbon here. And in case you remember, the first carbon is having OH down here, H up here, and again this is also OH. I'm like, tired of drawing the same, but just to help you, I'm drawing this. So this is again going to be H and this is going to be OH here. Similarly, this is going to be OH and finally this is going to be H. There is another H here. So what this is your alpha D glucose, right? Okay, now I'm drawing another glucose molecule so that I can relate how this amylose is forming. So this is your another molecule, right? This is your another molecule. There is one bond here, another one. There is the remaining. So this is again your CH2OH, the last carbon here. This is your first one again. So this is going to be H out here. This is going to be OH here. Similarly, this is also OH. And then you have your H here. This one is different from rest of that. So this is only H out here and OH in here. Similarly, this is again OH and this is your H. So this is again your alpha D and glucose, right? Alpha D glucose. So how this bond is formed, you do know. One of the glucose using its OH, another one is using its H. So what happened? A water molecule comes out here. A water molecule comes out here, and this way it results formation of a bond here, and this bond is your glycosidic bond. This is your glycosidic bond here, right? Okay. So this way, this keeps on going, inside the amylose. But and that's why amylose is a straight chain. But let me explain you how the amylopectin is formed, right? So right now what I'm doing, in amylopectin there are straight chain, but there are some branches as well. So what I'm doing, I'm just removing this amylose from here and I'm trying to get you how amylopectin is formed. So this is basically representing now amylopectin. So what is the difference between amylopectin and amylose here? To make you understand why this amylopectin is having branch, now I'm trying to help you out here with the branching here, right? So what happened? I'm drawing a structure right here. I'm drawing a structure right here for another alpha D glucose molecule, and I'm not drawing rest of the bond because you do know. So there are some bonds and hydrogen, etc. Now concentrate here this sixth carbon here. So this is your sixth CH2OH. So this is your first carbon and that's your sixth carbon. This is your sixth carbon here. This is your sixth carbon, this one. So what happened? Again, right from here, a bond is developing. A bond is developing between C and O, and during that, a water molecule also, comes out. So there is the bond between first and the sixth, and this result formation of the branching in the amylopectin. What that means? In amylopectin, there is not only straight chain of alpha D glucose, but at some places there are branches, and that branching is occurring at the at the first carbon of one alpha D glucose involving the sixth carbon of the another alpha D glucose, right? And in case you are confused, let me draw this here. This was your H. This is your OH here. Again, this is your OH, right? This is your H. Again, this is your H out here and there is OH. Similarly, this is your OH and finally you have H up here. So what is, just pay attention here. This is very important. That the first carbon of one glucose and sixth carbon of another glucose is having an additional bond, and that is responsible for the branching in the amylopectin, right? So let me wrap up everything or give you a recap of starch so that you are sure what I was talking about. Starch is a polysaccharide which consists of only alpha D glucose, right? But the starch is divided into two units. One unit is only 15% and it's called amylose. Other unit is about 85% and it's called amylopectin. Amylose is water soluble, however amylopectin is water insoluble. Amylose is having only bond between the first and fourth carbon, so it's just a straight chain, polymer. But amylopectin is not a straight chain only, but it also has some branches. The branching is taking place between the first and sixth carbon, but the straight chain formation is just like the amylose, where the bond is forming between first and fourth carbon of two adjacent alpha D glucose, right? And I tried to make you understand how amylopectin actually exists. So this is the structure, I try to make you go. One last thing before I wrap up this lecture is there is no difficulty. I tell you what, there is no difficulty. What you can do, you can practice, right? Because once you practice, you're definitely going to get it quite an easy way, right? So I must tell you that, you know, there are things that doesn't come so easy, right? It may be one of such topic, but I believe, you know, this is again very easy. Not some rocket science and all, like I usually say. So just practice and let me know, you know, how good or bad this was. So thanks for watching. Take care and good night.